Hello, my name is Danny, and today we'll be talking about the three different types of collisions and how to find the center of mass of an object. First, we'll begin with elastic collisions. Elastic collisions is where both the momentum and kinetic energy are conserved. Almost no energy is lost. For example, two rubber balls. Now, these aren't rubber, but let's pretend they are. If I were to clash them against each other, they will bounce perfectly back in opposite directions with almost the same amount of energy they had before, because the momentum and energy are both conserved. Now, let's talk about inelastic collisions. This is where the two objects' momentum is conserved but not the kinetic energy. The energy is converted into sound or heat, for example, a car crash. Now we're gonna simulate. Say a car is standing still and another car crashes into it. This car will bounce that way, and all that energy will be converted into heat and destruction of the crash. Now we're gonna talk about perfectly inelastic collisions. We're gonna pretend these pennies are magnets, and let's say I were to push one penny into the other. If they were magnets, almost all kinetic energy will be lost, but the momentum will be conserved, and the objects will keep moving in the direction of the first object pushed the other one into. So I'll push it, and they'll stick together and keep moving in that direction because the momentum will be conserved, but not the starting kinetic energy. Now, we're going to talk about how to find the center of mass of an object. We're going to be using this dry erase marker. The starting point weights about, you can use anything in your starting point, but my starting point is going to be this, and it weights around 3 grams. And your end point, my end point weights around 7 grams. The dry erase marker is about 12 centimeters in length. As you can see, it's like about, there you go, like about 12 centimeters in length. So now that we got the variables down, we're gonna plug them in. The formula is the sum of its individual masses times its distance from the starting point, all divided by the total mass in the system. So the total mass in the system is 10, because 3 plus 7 is 10. So we know that's our denominator. Now we're gonna find the top number. And to do that, we're gonna equal our starting point, which is 3 to 0, and then equal our end point, which is 12 centimeters. 7. We're gonna times that times 12, and you get 84. So 84 is our top number. Now you're gonna get 84 and divide it by 10, and you're gonna get 8.4. Now 8.4 is about 3/4. You could say is about 3/4 of 12. So I think it's a pretty accurate number, and that's how you find the center of mass of an object. Thank you. My name is Danny Gonzalez.